All right, chapter 3, decision structures and Boolean logic. It shouldn't be too complicated, shouldn't take too long, so we'll see how it goes, if we can cover all of this chapter today. Let's start. All right, so these are all of the topics that we're going to cover today. Just the main things that you need to know about control structures is the terms and how they work. Everything else will come as you will continue working with these condition and decision structures. So the only thing that's important, focus on the terms and just knowing what those mean. And these are the first three terms that we're going to cover today. The first one is control structure. Basically, think of it as a logical design of how your statements will execute. So just the idea, the logic behind of how the statements execute. Then there's a sequence structure, and that's just a set of all of the statements that are in front of you and the order in which they appear. And then the decision structure is the main part of all of this, is the specific actions that are going to be performed whenever a certain condition exists. And these terms do not have to make sense to you right now. Just keep them in mind as we go through these topics. All right, moving on, the if statement. So the if statement is the most basic one, the one that we're going to begin with. Let's do a little recall of flowcharts. So flowcharts help us design our program, and they follow the actual code of your program, the flow of your program. That's where the flowchart comes from. So if you have a decision structure, such as the if structure, the if-else structure, it's going to be represented in the diamond shape. A diamond shape will represent a true or false condition that your program will test. So there's going to be some certain condition that's going to be tested for either true or false. And then based on the result of that condition, a certain action will execute from your code. Now, the first one that we're covering, the if statement, that's also what's called single alternative decision structure. Now, these terms are important because there's only three of them: the single alternative decision structure, then there's the dual alternative decision structure, and the multiple alternative decision structure. Now, the first one, the single one, it comes from the name. This structure will only provide one alternative path of your code execution. What that means, that a certain condition is going to be tested, and then if it's true, something's going to happen inside of your code. Now let's look at an example. For example, this is a if statement single alternative decision structure example. So we're coming in right here where this arrow points, right here, coming in right here. And remember, I told you the condition is inside of a diamond. So the condition that we're testing in this example, we're asking, is it cold outside? If it is cold outside, we're going to follow the true arrow because it is cold outside. And we're going to perform an action of wearing a coat. However, if it's not cold outside, we're going to skip this thing as a whole, and we're just going to move on with our life, with our code. We're just going to continue like nothing happened. So the point of these conditions is to test certain scenarios, certain things that might happen during your code execution, and perform certain actions. Now, moving on, this is the syntax of Python and using those statements in Python. So you're going to put a keyword if, and then you're going to put your condition. Now, your condition can be literally anything. You can be checking for a password that matches a certain combination, or you can be checking if a person's age is more than 21 or less than 21. You can be checking that. Anything that comes into your head, anything that you can't check and you can ask a question, you can put it into a condition. So this is just a general syntax. So you're going to put the keyword if. After that, you're going to put your condition, whatever it is. Then you're going to follow that condition with a colon. And then after that, you're going to put whatever you want your code to do if this condition is true. I'm going to show you another example in a little bit. So the first line, the if condition is known as the if clause. Just think of it as the if statement. If you see the keyword if anywhere in the code, should be like a reminder to you that you are using single alternative decision structure, or you're using some sort of decision structure if you see if. Now moving on. Now those conditions can consist of many different things. Now those conditions mostly consist of Boolean expressions. Now, Boolean expressions, let's recall what Boolean is. Boolean is a data type that we use inside of our programs, and those data types, Boolean specifically, can either evaluate to true or false. So that data type can only hold two values, true or false. That is why we use them with our decision structures, because our decision structures will also evaluate either to only true or false. Now, here's an example of a Boolean expression. A is greater than B. So we're going to be checking if A, whatever that number is greater than the number B. Now, if it's true, then this expression will evaluate to true, A is greater than B. If it's false, then A is less than B. So pretty simple right here. And the only other thing to know about this Boolean expressions, these right here are called relational operators. Relational operator is going to determine if there's a specific relationship between the two values that you're comparing. And there's a couple of relational operators. Here they are. So we can either check, in this case, we can either check if the number is greater than some other number. If the number is less than some other number, then these relational operators come in. Those relational operators are checking if the number is greater than or equal. This one tests if the number is greater than or equal to another number. And the other one tests if the number is less than or equal to a certain second value. Now, this operator right here, double equal, just determines if two values are equal. So for example, if you have 4 and 4 and you're checking if they're equal, it will evaluate to true. If you're checking 4 and 5, if they're equal, this will evaluate to false. So literally just checks if two of the values are the same. And this one is the opposite, the exclamation point and a equal sign. This one determines if two operands are not equal. So if two values that you have, if they're not equal, only in that case, your expression will evaluate to true. Here's the table of what we just talked about, all of the relational operators. This is inside of your PowerPoint. So if you want to look at it, if you want to save it somewhere, you're welcome to do so. Here are all of the meanings for all of the operators, with X and Y being some sort of values that we have. Now, this is how your Boolean expression can be used with your with your decision structure. In this case, we're coming in the same way. We're coming in from the very top, and we're checking if whatever value is stored inside of our sales variable is greater than 50,000. Now, if it is greater than 50,000, then we're going to assign a bonus of 500. I would assume that this is for some employee, evaluation of employee or a department. So if that department produced 50,000 sales in a certain period of time, then that department will get a bonus of 500. If they did not produce more than 50,000 sales, nothing's going to happen. We're just going to continue with our code. And this part, we will never even get to this part of code. Now, any relational operator, you can use any relational operator that you want to perform to check any sort of decision structures, any sort of decisions that you need to check. You can use any relational operators. Here's an example of using the equal sign. So if the balance equals 0, something would happen. And another example, if payment doesn't equal to balance, also something else could happen inside of your code. Now, this is how we do it in Python. You can also write it in one single line. So if you only have one statement that you want to one statement that you want to execute, then you can put it all on one line. So in this example, we have if. This is just the general syntax. If some sort of condition happens, then do something. And in this example, if our score is greater than 59, we're going to print you passed. So for some student, if their test score is greater than 59, we can say that they passed that test, exam, quiz, whatever. Now, moving on to dual alternative decision structures. Now, these are a little bit different because they provide two passes of execution. So everything that we saw before was just one pass of execution. If something happens, do this. Now, in this case, what we have, dual alternative decision, if something happens, do this. However, if this thing doesn't happen, do something else. So in this example right here, we have our if condition, and we have whatever condition you want to check. If that condition is true, this part of code will execute. However, if this condition is not true, we will not just stop executing our program. That's not what's going to happen. We're going to move on to our else. So if this condition is false, we're going to execute our else, whatever's inside of the else. Now I'll show you an example of this right here with a flowchart. So we're coming in, as you can see, we now have two different paths of execution. Before that, with our flowcharts, we only had one. If that execution would not come through, we would just continue carrying on with that code, right? We had our little arrow right here. However, we do not have that arrow anymore. Instead of that arrow, we have an extra path that we can take. So let's look at what this flowchart means. If our temperature is less than 40, we're going to follow the true. If that is true, if this condition is true, temperature is less than 40, we're going to print a little cold, isn't it? However, if our temperature is greater than 40, we're going to follow this path right here, and we're going to print nice weather we're having. As you can see here, again, this is just the another example. So if the condition is true that you put right here, if your condition is true, all of these statements will execute. However, if the condition is not true, we're going to skip all of these statements, and we're going to move to these statements right here, and these statements will execute. So just think of it, if condition is true, execute the first thing that you see. If condition is not true, do not execute these, execute the second part of your code that exists inside of your dual alternative decision structure. You can also compare strings in Python. It's a little bit of an interesting way to compare strings. It doesn't really work the same way as you think it would work. However, it is possible, and string comparison are case sensitive. And what that means, if you have all caps, the word dog, and all lowercase, the word dog, those two are completely different strings, completely different words for your computer. For Python, these two are completely different. So just make sure when you're comparing strings that you're comparing them with the right either uppercase or lowercase, because if you compare two different types of letters, it will cause a problem. They won't be compared in the right way. Now, these are all of the operators that you can use when you're comparing your string. So greater than, less than, greater than or equal, less than or equal. However, those characters that are inside of your string, they're going to be compared using the ASCII values. And let's recall from PLD 101, I think it was chapter 1, so it was a while ago. ASCII is a way to for us to use the binary system, because the computer uses the binary system, zeros and ones. It's the way to take those zeros and ones and transform them into letters in plain English. So each character has a certain ASCII value attached to it. I don't remember them by heart, but I think A is something like 69 or 68, something around that. So each letter will have a number associated with it based on the ASCII table. And you can Google ASCII table. It's going to be the first thing that's going to pop up, a big table with all of the values and all of the letters that you know, the letters and the numbers that those letters represent. Now, what happens when you compare those strings in Python, it's going to be character by character comparison. So the first character is going to be taken from the first string and the first character from the second string, and those two, their ASCII values are going to be compared. Now, if the words are the same, then of course, if you compare those strings, those are going to come back as the equal strings. But if they are not the same, then different things might happen based on your condition. But the only thing that you need to know is that the string comparison in Python is based on ASCII values. Here's an example. We're comparing Mary to Mark. As you can see, each letter represents a certain number. So M is 77, A is 97, R is 114, then Y is 121, and K is 107. Since the last letter K is 107 and Y is 121, this string Mark will appear to be smaller than the string Mary. Even though they have the same amount of characters, they start with the same letter, they have the 3 letters that are the same. However, since K is at 107 and Y is at 121, Mark is considered to be a smaller string than Mary. And I know it might be a little bit difficult to comprehend that. Just the only thing you need to know is that each letter has an ASCII value, and those values are compared instead of the actual letters. Now, nested decision structures. So here's where the multiple decision structure comes in. Instead of just testing for instead of just testing one condition, you can test multiple conditions if you're using the multiple decision structure. Example right here. If we need to determine if someone qualifies for a loan, there's going to be multiple conditions, right? That's going to evaluate that person if they're qualified for a loan. But in this condition, in this example right here, we will only have 2 conditions. That person must earn at least $30,000 per year, and that person must have been employed for at least 2 years at their job. Now, how we would check those conditions, we're going to check the first condition first. If that one is true, then we're going to move on to our second condition and see if it's true. And after that, we're going to perform some actions. Here's an example of that. The first one, as I told you, we're going to be checking if the salary is greater than or equal to $30,000. If it is true, we're going to follow this arrow right here, and then we're going to check our second condition. Remember that the conditions are in the diamond shape. So we're going to follow this arrow and see if that person has been on the job for 2 or more years. If it is true, we're going to print you qualify for the loan. If it is not true, we're going to print you must have been on your current job for at least 2 years to qualify. Now, if the person's salary is less than $30,000, then we're not even going to get to this part of our code. We're going to follow the false line because our condition evaluated to false. We're just going to print you must earn at least $30,000 per year to qualify, and we're going to exit our code. So you have to be very careful when you're creating decision structures because of this thing that you might not even get to check the second condition only because the first condition is false. So just think logically about it when you're creating them and make sure that you're checking the right conditions in the right order. Put an indentation. You don't really need to know that because your Pearson Revel platform will indent your blocks of code immediately by itself, automatically. Now here is a special version of this if else statement. So how we would use the multiple decision structure. As you can see here, we're testing our first condition. So if something happens, we're going to do this. If that doesn't happen, we're not moving on straight to else. No, that's not what we're doing. We're going to move on to our second condition. Then we're going to check our second condition. If something happens, if that is false, move on to the third one, and so on, move on all the way to the bottom. So we're going to be checking all of these conditions. Alignment. Here is an example of a big nested decision structure of checking somebody's grade. As you can see, we're starting at a score being greater than or equal to 90. They're using a 10-point scale. So if their score is greater than 90, your grade is A. If it's not, move on and check a lower score. So if it is greater than 80, print B. If it is not, check a lower score. If it more than 70, print C. If it's not, again, check another score, 60, print D. And then at the end, well, if it's not 60, then their grade is F. So just print the grade is F. Logical operators. Now, this is a very important part of coding. You will see these a lot when you will be working with Python or Java. Logical operators are basically everywhere. So logical operators, why would we use them? They combine your Boolean expressions. So if you want to create a condition that is more complex, you can use logical operators to create that condition. Now, there's only 3 logical operators that exist, and or, and not. Now, the AND operator and OR operator, they are binary operators, which means they will combine two Boolean expressions. However, the NOT operator is unary operator, and that means that it will only work on one Boolean expression, and what it does is going to reverse the truth of that Boolean expression. And I'll show you an example. Let me see if there's an example somewhere. Yeah, so here's an example of how to use those operators. Now, here's our example of checking if the number is within the range. Now, we have one condition right here. This is our first condition. X is greater than or equal to 10. And this is the second one. X is less than or equal to 20. Now, we could check, we could use these two Boolean expressions and put them as their own conditions, right? We could check if the number is more than 10, do something. If the number is less than 20, do something also. However, if we need to check them at the same time, that's where we would use our logical operators. In this case, we're using AND because what's going to happen, we're going to check if X is greater than or equal to 10, then, for example, it's 12, right? We're checking if 12 is greater than 10, this one will evaluate to true. And then we also check if X is less than or equal to 20. So this AND will combine the two expressions for us. Now, if we had, for example, we had a number 12, now this would be also true because 12 is greater than 10 and 12 is less than 20. So what's going to happen? This whole expression, this whole complex expression will be evaluated to true. Now, the other one, or is usually used to check one or the other. So you're going to check if your condition is this or this. Now, in this case, we're checking if X is less than 10 or greater than 20. So we're checking if the number is outside of a specific range. Now, let's take, for example, number 7, right? So we're going to check is X is less than 10, number is 7, so this is true. And then we're going to check, or X is greater than 20, well, this is false. However, because we have our one true right here, this whole expression will be evaluated to true, this big expression. Now let's go back and I'll show you the how those operators work. Again, these are all inside of your PowerPoints. If you're using the AND operator, here are the results of your expressions that you might have. So if two of your expression each evaluates to false, false and false, then the value of your big expression that is connected with the AND operator is going to be false. If your expression evaluates to false and true, still we get false. Now, true and false, the same idea, false. However, if both of your expressions evaluate to true, only then the big expression will be evaluated to true. So that's the only thing that you need to know. And evaluates to true only if both expressions are true. Now, or is the opposite. Or evaluates to true in any scenario unless both of the expressions are false. As you can see here in this table, at the bottom, false and false, only in that case, it will evaluate to false. Everything else will be evaluated to true. The not operator is fairly simple. If your expression is true, the not operator will make it false. If your expression is false, the not operator will make it true. So it's going to just negate the value of your expression. Boolean variable, again, a little recap. We already did it, but I'll just go over it again. Boolean variable can only reference one of the two values, either true or false. In Python, it is this is the way you would put the data type, BOOL, which stands for Boolean. Boolean variables are commonly used as flags, and what those are, it's just gonna signal to your program when a certain condition exists. So once your flag is set to false, for example, because the only two values, true or false, if it's set to false, condition does not exist inside of your program. If that flag is set to true, the condition exists inside of your program. Conditional expressions. All right, let's see. All right, that was it for today. Let me stop recording real quick. Stop recording.